Welcome to the Center for Sustainable Polymers Beyond the Classroom series. Presenting today is Dr. Annabelle Watt, Managing Director of the Center for Sustainable Polymers.
Thanks for the opportunity to talk about this really exciting project that we got to undertake called PELICANS. I want to start by just really acknowledging all of our partners on this slide. This was an opportunity that was presented to us by a partnership between the National Science Foundation and Australia's National Science Agency, CSIRO. And with that, we were able to partner with a variety of different organizations, which include the Australia Packaging Covenant Organization, APCO, as well as interact with the ANZPAC Plastics Pact, and our university supporters, University of Minnesota, University of New South Wales in Sydney, and Monash University, and then the SMART Research Center, as well as the Center for Sustainable Polymers. So this was a lot of planning and coordination to have 2 weeks in a different country and in a different location than we're used to being. And so then I just want to thank all of them for all of their work in creating this program and bringing this to fruition. So PELICANS is plastic in the environment, leaders and innovators collaborating from Australia, New Zealand, and the United States. And I was able to lead the design and execution of this program. And really where this came from is the connection in research and innovation between the two national science organizations within the 2 countries, one in the US and one in Australia. And they both have an aligned mission to promote innovation and support international activities to strengthen the knowledge and infrastructure and capabilities of researchers. And so then aligned to the CSIRO's Ending Plastic Waste mission and the work that we do here in the Center for Sustainable Polymers, we're able to design a 2-week research forum supported by these organizations to focus on the pressing challenge for the environment, economy, and society, which is the circular economy for plastics and ending plastic waste. And so then I wanted to start the stage with what is the circular economy? And really, I will point you to the vast number of resources that the Ellen MacArthur Foundation has really set the stage for what circular economy means. I took this snapshot of their website because it is a series of videos. I know people learn in different ways, and so if you want to watch videos about how to think about the circular economy principles or read articles, their website really has a lot of content that you can go down a rabbit hole with. But I want to read aloud the circular economy definition. It's a systems solution framework that tackles global challenges like climate change, biodiversity loss, waste, and pollution. It's based on 3 principles driven by design: eliminate waste and pollution, circulate products and materials at their highest value, and regenerate nature. And so then the way that I formatted this talk is going to be a little bit more in line with the circular economy principles and less a serial digest of what we did during our 2-week PELICANS experience. Because of the circular economy framework that Ellen MacArthur has put out, they also have convened a network of commitments to a plastic pact. And so then I also want to highlight that the ANZPAC Plastic Pact and the US Plastic Pact also exists, as well as other national plastics pacts. And what they really do is they bring together organizations to participate and commit to these ambitious goals to advance a circular economy, specifically around plastics. And so you can see the parallels here. Their websites are really detailed and they have updates about what what they're doing and what their achievements have been. And so I will direct you to those two websites to get more. I pulled this bullet point list, but it's really around how do you eliminate unnecessary plastic use? How do you, design for circularity? So have it be reusable, recyclable, or compostable, and then create demand for recyclability or recycled content by utilizing recycled materials. And so a lot of these goals are really in alignment with that circular economy principle. So then when we think about Australia, they're, one of the things that we learned is they have some really strong national strategies. And so then they have a integrated circular economy strategy that CSIRO has put out. It's a roadmap for not only plastics, but glass, paper, and tires. And it really is looking at where is the challenge today, what's the infrastructure today, and what are the priorities moving forward to really think about that circular economy for each of these categories, because each of these categories are distinct in their materials and how we utilize them and how they get collected. And so then when we look at plastics, we think about, the design and manufacture of them, use and collection, recycling in terms of their material flow. And then you can think about the enablers, whether there's a market for that, whether we have a culture for it, and there's consistent governance for it. And so I pulled this from their roadmap. It says there's no single silver bullet for this transition to a circular economy in plastics. There are many types of plastics, and challenges are numerous and often interconnected. However, the biggest single need that they identified through this report is to create more markets for recycled plastics, which will underpin the confidence for investors to build recycling infrastructure. And so I think that's what we see in our society today is the challenges and the tension between the act of recycling as well as the market for recycling, and where it all ends up and how you support that material flow from that high up national strategy. So what is PELICANS? If you couldn't tell already, I picked the acronym before I picked the words of the title. So the title is really long so that it can be called PELICANS. And what we did with this program and our intent with this designing such a program is really to embody the principles within the Beyond the Classroom series. We want to supplement that traditional academic training for researchers at the intersection of sustainability and polymer science, increase exposure to current research in all the sectors, as well as the current challenges in the plastic production and waste ecosystem, and see innovation actually take place in practice. We want to appreciate that interdisciplinary nature, so we want to bring people together that have very different backgrounds and skill sets, and equip participants with the systems level thinking about the entire plastics ecosystem in different global regions. So we set out these goals, and we put together a schedule of 2 weeks of experiential learning in Australia. So this is the only time that I'll really focus in on this 2 weeks of programming at a high level. But essentially, the first week we spent in Sydney, the second week we spent in Melbourne, and you can see the divide between how we spent time in the classroom, doing symposia and poster sessions, as well as having workshops. And then we spent half of the time also doing tours, right? Seeing what happens at various facilities, some of which I will highlight during this presentation. And this took place earlier this year, almost 10 months ago, I'll say. And the and I want to again thank all of our partners and supporters in their effort in coordinating this event with us, because without partners like CSIRO, without the APCO partnership, without our university partners, we wouldn't have been able to pull together such an ambitious set of programs. So I'm going to start with where everything comes from in terms of when we think about plastic circularity, right? So we took a tour of the sole polyethylene manufacturer in Australia, Monash, and you can see us. We were able to tour the actual facility and the plant by bus, but because of security and safety, we couldn't take any photos. So I only have photos of us in the classroom. But we got to learn about what Monash does and where they fit in the entire ecosystem of plastics manufacturing. Essentially, they utilize ethane and gas oil feedstocks that they pipe in from other places within the country, and they produce olefins, so ethylene, butadiene, and propylene. And then they produce a variety of polymeric materials, one of them including polyethylene. And they are then suppliers of polyethylene to customers who turn those pellets into products. And so then spending the day there, we got to learn a little bit about, how Australia has refineries and where they have resource to have this as their sole manufacturer of polyethylene. And so then on the left, I was able to pull a map of where refineries are within the country of Australia. And I grayed out the rest of the picture on the right, but essentially, the traditional route would be you take crude oil, you pipe it into a refinery to get processed and then be delivered as chemicals for a variety of different applications. And one of the interesting things that I think Monash does is that they actually have quite extensive equipment and processes on site, not only for quality control and integrity. So you can see on, if we can see on the, let's see, where's a pointer? If you can see, oops, on the right, they are looking at, the quality of the pellets and the pellet agglomerate, the pellet size, the pellet shape, and then, whether they're clumping or not. And so these are all process-driven parameters that you can do to impact the quality of your pellets that you create. They also have a vast suite of thermal property characterization and a full lab, analytical lab, to test all of their materials. One of the really interesting things that I took away from visiting them is that they actually have a large floor full of product development equipment. So they have a line to test blow molding of milk jugs using high density polyethylene. They have a blown film line, and they also have extrusion for pipe making. And a lot of that is not because that they are producing those products, but they are producing those products in partnerships with their customers and making sure that the materials that they're making are really aligned to the needs of their customers. And if you have ever looked at a list of the different grades of polyethylene you can get, it's pretty vast because they have very different thermal and mechanical properties, and they are suitable for those different processes. such as blow molding or maybe pipe extrusion. They're going to have different rheological profiles. And so then they have in-house all of that capability to be able to test the resins that they're creating and align them with the application of their customers. One other thing that I do want to mention is that they also have a white paper around testing for recycled content. So because they have this testing capability on site, they're able to pilot and test and get analytical data on recycling resin in milk jugs. And so then they have this, they have essentially put out a white paper on all of that data, how it impacts the material performance, the color, and what factors influence that, whether it's cycle time or the amount of times it's recycled. And so I will point you towards their white paper to learn more about their recycled content technical report. So then when we think about, you know, actually how does that play into a circular economy? We can think about how it's applied in different ways. So one of the presentations that we heard from one of the symposia days was CHEP. They, took on this challenge of interviewing customers and industry and identifying the patterns within the wide network of people that they surveyed. And the challenges were really around eliminating waste, eradicating empty transport miles, and cutting out inefficiency. So then, because e-commerce and a variety of on-demand, small package shipping makes it so that our consumer demand requires much more shipping logistics, transportation logistics. We also end up with the challenge of having inefficiencies when we're getting a very small item shipped from the warehouse that it's originating from. And companies were really looking for collaborative solutions and to solve those challenges together. And so then the way that CHEP has done this is a little bit more on the reuse or prevention side, where they've really looked at shipping logistics as a way to provide circularity in moving goods around. And so then instead of pallets going from one place to another and thing like products, food products, fruits and vegetables and anything else that might go on a pallet or in a box are replaced with a reusable form factor. And those are all coded and identified and able to be traced so that you're only essentially renting the item when it's in your possession as a distributor or a producer. And then it then gets sent over to, the next person in line to be able to get collected and tracked in that way. And so then you end up with a lot less, not only like pallet wrap, but elimination of potential waste from boxes caving in, as well as just somebody being responsible for that reuse model or recirculating model. So that's when we think about business to business movement of materials. What happens when we think about the materials getting into consumers' hands? And so then this is where one of the tours that we did was with Tomra Cleanaway. And the way that this scheme works is that they have a collection scheme. It's nationally coordinated. And what you do is they have these, I actually found this before we went on the tour, was they have these reverse vending machine sites. And the reverse vending machines can not only take single bottles, but can take large buckets of, bottles. And what happens is that each one gets scanned and identified on the way in. So they have a lot of technology on the when the material is being put in. And then you can see in the inside of like behind the scenes of the reverse vending machine, you have it being sorted in different bins. And it does make it so that it does limit how many things you can accept per single reverse vending machine. But it also makes it so that you can adequately receive it and provide the vouchers for that 10-cent refund per bottle. And so then they have a variety of apps, or you can just get a ticket and you can get your money back for all of those deposits. And there's a lot of technology that goes into making sure that there's the bottles don't have liquid in them. The reverse vending machine really helps people understand how to recycle. So it can't have heavy liquids in there. It should be empty, and it should have a barcode, and all of those systems have been put in place. They've had a lot of learnings in implementing that, and so this model is being utilized in a variety of different regions. And so and it works in terms of being able to collect these materials. So then what happens when they collect them? Well, it then goes to a sorting facility, and we were able to tour that and see how it acts a lot like a materials recovery facility, where it's sorting the different types of bottles, the different quality of bottles, and separating glass and plastic if it wasn't already sorted at source. And then this is their complex map that we're looking at of where all of their collection centers are, what type of vending machine that they have, whether it is a reverse vending machine, whether it can take bulk materials, or whether it's a store drop off. One of the things, as you get more and more of less urban, more rural, you have less of an opportunity to put up a big piece of infrastructure to collect it. And instead what they do is store drop off type of models, but it's very suited to the place and the activities of that community. And so then really when we think about the circularity of this, what they really envision is that you're diverting a lot of these materials from landfill, you're collecting it in some way for processing, you're able to sort and treat it upon collection. And then one of the things that we learned about on our tour was around how they're turning, we heard a presentation from Viva Energy, as well as we toured APR, and they were really looking at how to transform these materials into plastic pyrolysis oil and then feed that back into that refinery process to really circulate those materials and create that circular economy. And when you bring it back to pyrolysis oil and bring it into the refinery process, you end up with not only technical challenges, but you end up actually bringing the molecules back so that they can make as close to, they can make the materials that we think about when we think about virgin resins, except that they do have, they have the molecules circulated from waste. And so then that's what Viva Energy Australia is really advancing when we think about how they are able to take in that feedstock. They're really working on that co-processing activity. And while we didn't get to tour Viva Energy, we did get to tour APR, which actually had a smaller converter for for generating pyrolysis oil, and being able to see that as a raw material and pilot that. And so then I think when we think about finding that common language for the circular economy, we end up talking a lot about not only the technical challenges, but really how are companies working together, how are suppliers working together, how are we creating innovations to support not only the technological innovation like turning plastic into pyrolysis oil, but innovations in terms of collection schemes or the technology that's needed to support reverse vending. And what I'll say is, we were able to learn a lot, not only from, working, touring a lot of these facilities, but we were able to have a mixed cohort of graduate students and postdocs, both from the US, from all over, from a variety of different programs within the country, as well as folks from Australia, and we were able to interact and learn together. The other thing that I think I really want to highlight is the opportunity we had to facilitate workshops and group learning activities. We had a innovation facilitator that is at CSIRO, and she did a great job in templating how we think about and learn about sustainability, what that means. Less about what is the definition of sustainability, but if you can see in the middle photo there, how we think about it across the PESTLE framework. And then, the other thing that we asked a lot of our participants to do was reflect daily with structured prompts. So after every day, there was a practice related to writing down the reflections of what we learned that day and how it's impacting our holistic thinking and how it's and we were able to, as the facilitators and program leaders, provide those prompts so that we can reflect on those learnings. There were a lot of things that I didn't touch on, mostly because I wanted to keep this short and sweet, and I kind of wanted to convey some of the learnings that we had as we follow materials from the production of polyethylene and how we think about the circular flow of materials all the way through. What I didn't touch on was, all of the detailed work that the participants did in terms of their learnings. We also toured some other facilities that I didn't touch on. And we also took a microplastics collection experience. And I'll end on this. I think one of the things when we think about the Beyond the Classroom series is, how do we have experiences that are different or that kind of expose us to a new way of thinking? And so then, trying to collect microplastics, what type of netting we're using, how fast we're going, what direction we are, where we're at. It gave a sense of field work where when our center is focused on in the lab doing chemistry or on the computer looking at models or thinking about process engineering, when we think about a giant chemical plant, we might not think about what it takes to do field work and think about how to collect microplastics to study what those plastics look like. And so then that was a really enriching experience for us as a group. And so with that, I'd like to say thank you, and I'm happy to take any questions.